Okay, welcome to um, another marathon. This time I have questions from hypothesis testing of the population proportion using the binomial distribution. Let's start looking at the questions. The first one says Jacques is a chef. He claims that 90% of his customers are satisfied with his cooking. Marie suspects that the percentage is lower than 90%. So what I am talking about is P is equals to 0.9 and P is less than 0.9. Okay, she asks a random sample of 15 of Jacques' customers whether they are satisfied. She then performs a hypothesis test of the null hypothesis P equals to 0.9 against an alternative hypothesis where P is the population proportion of customers who are satisfied. She decides to reject the null hypothesis if fewer than 12 customers are satisfied. Okay, so her rejection region is basically X is less than 12 customers. In the context of this, explain what is meant by a type 1 error. So I have H naught and H1 in front of me. I'm going to say that H naught means rejecting H naught when H naught is true. So in this context, I am saying that um, less than 90% customers are satisfied when actually more are satisfied. Okay, that's the type 1 error. Find the probability of a type 1 error. So probability of type 1 is basically probability of the rejection region. So I'm going to say that this is the probability of x less than 12. Okay, since I've asked 15, I can just say that I wanted probabilities from 0, 1, 2 up till 12. So I can just do 1 minus probability, not up till 12, up till 11, 12, 13, 14, and 15. So I'm going to write 1 minus 15C12, 0.1 power 15 minus 12, and 0.9 power 12, minus 15C13, 0.1 power 15 minus 13, 0.9 power 13, 15C14, 0.1 power 15 minus 14, and 0.9 power 14, and minus 15C15. So I've got to write all of this before I can go ahead and calculate. But I'm going to use my calculator intelligently and tell you that I can actually just do this on a calculator. I don't need to type so much. My calculator is capable of cumulating the binomial distribution. So I'm going to say binomial and I'm going to cumulate. Now remember that cumulates always to downwards. So I want probabilities up till 11. So that's what I'm going to say. N is 15. Okay, that's also something that I know. Zero point 0.9 is my success, and I want it to execute. So I get 0.0555. Okay, 5.55% is my probability of a type 1 error. 556. Let's call that 556 because there's a rounding off. Okay, so it's very simple when you want to cumulate downwards, and you can use your calculator to do that. Then says Jill shoots an arrow at the target. Last week, 65% of her shots hit the target. This week, Jill claims that she has improved, so it should be greater than 0.65 out of her first 20 shots this week. She hits the target with 18, so her test statistic is 18. Assuming shots are independent, tests Jill's claim at the 1% significance level. So I'm simply going to do what? I'm simply going to calculate the probability of x greater than or equals to 18. That's always true for binomial distributions, that you calculate the probability of whatever your test statistic is, and you put a greater than or equals to or less than equals to based on what your alternate hypothesis is. Okay, so I'm going to say that this goes probability of 19, 20, 18, 18, 19, 20, and that's it. Okay, so my calculator can't do individual accumulating to a top value. I will have to write this on the exams. I'm going to write 20 C 18 0.35 power 2 0.65 power 18, and I have to add all of them. So now my calculator can do what? It can give me a list. I am also fine with that. So I'm going to pull out my calculator again and tell you that I go to um, this time I go to binomial probability distribution, and I say that I want a list of 18, 19, and 20, and I want 15, no, I want 20, and I want 0.65. Okay, let's execute. Okay, pretty small values. Let's combine them. 9.985 into 10 power minus 3, 1.952 into 10 power minus 3, and 1.812 into 10 power minus 4. Then I go to my normal mode and I calculate these. So 9.985 into 10 power minus 3 plus, I could have also done decimals, but since my calculator gave those values, I persisted with that, and now 1.812 into 10 power minus 4. So I have all the numbers. This gives me 0.0121. Okay, so what do? I compare 1.21% is greater than the 1% significance level. So I'm going to say that I accept H naught. Jill's performance has remained the same. There is no evidence to it improving. Okay, question number 3. An engineering test consists of 100 multiple choice questions. Each question has 5 suggested answers, only one of which is correct. Okay, so probability of success is 1/5. Ashok knows nothing about engineering, but he claims that his general knowledge enables him to get more questions correct than just by guessing. So he says that his probability of success is greater than 1/5. So if you were guessing, your probability of getting it right would be 1/5, but he says he can guess it better, so greater than 1/5. Ashok actually gets 27 questions correct. So n was 100, and the test statistic came out as 27. Use a suitable approximating distribution. So I'm telling you to use an approximating distribution. This is by definition a binomial. I want to calculate the probability of x greater than or equals to 27. Now since n is large, and let me check, np is 100 into 1/5, which is 20. So that's greater than 5. nq 100 into 4 over 5, which is 80. That's also greater than 5. So those conditions for the conversion of a binomial distribution to a normal distribution are met. Therefore, I'm going to convert from a binomial to a normal, and I'm going to say that what I want to do is I want to do a continuity correction first. So I get probability of x greater than 26.5. All numbers that round off to 27 or greater are being considered here. So I will do z is greater than 26.5 minus np over root of npq. Okay, what's n? 25.5 minus mean. NP is 20, that's what I just calculated, and NPQ would be 20 into 0.8. Okay, let's do that on our calculator. 1.375. Probability of z greater than 1.375. 1 minus 5 of 1.375. I don't know why the answer is missing here, but let's just quickly go to our table. 1.375, 1.37, and 5. 1.9155. 1.9155. 0.9155. So that gives me 0.0845. Okay, so what was the significance level? Greater than 5%. Therefore, except H naught, no evidence that Ashok is better. Ashok has better general knowledge. Okay. That was question 3. Question 4. At a certain hospital, it was found that the probability that a patient did not arrive for an appointment was 0.2. The hospital carries out some publicity on the hope that this probability will be reduced. They wish to test whether the publicity has worked. It is suggested that 30 appointments on a Monday should be used for the test. Give a reason why this is not an appropriate sample. Okay, Monday is only 1 week of the day, 1 day of the week. Okay, so biased sample. Or on the first 30 appointments, so early morning. That's another bias in the sample. A suitable sample of 30 appointments was selected, and the number of patients who do not arrive is noted. This figure is used to carry out a test at the 5% significance level. Explain why the test is one-tailed and state suitable null and alternate hypothesis. Okay, so P was 0.2, and I'm checking if it's less than 0.2. So it's one-tailed because I am testing for a decrease. Okay, state what is meant by a type and state a suitable null and alternate hypothesis. That is what I've already done. Okay, state what is meant by a type 1 error in this context. So rejecting H naught when H naught is true. So concluding that advertisement has been effective when it has not. Okay, part 4, using the binomial distribution to find the critical region and find the probability of a type 1 error. So how do I find the critical region? I have to come up with a number that will give me a probability that is less than 5%. That is when I reject H naught. So I'm asking you to find the rejection region, and these questions are always solved through trial and error. Now I know that I have to start with something x less than or equals to. I can start with any number that I want. Let's say want to start with the number 2. Okay. This is just hypothetical because um, I have to start somewhere. N is 30. Typically, I would start with zero point 0.2 times 30, which is 6. But it's absolutely fine if I want to start with 2 because it's a smaller number. I just want to calculate the probabilities of 0, 1, and 2. So I say that I go on and start calculating 30C0, 0.8 power 30, 0.2 power 0, 30C1, 0.8 power 29, 0.2 power 1, 30C2. Now my calculator, like previously, it can cumulate, so I'm going to use that cumulative distribution. I am not showing you my calculator on screen this time. I'm doing it quickly um, and directly. You can go back and look at the video. 2 30.2. So I'm getting 0.0442. That's very close to 5%. Let's see if probability of x less than or equals to 3 is also close and it's inside 5%. So I'm going to say that 0.0442 plus probability of 3. Let's see if I can get an answer out of that. That gives me 12.27%. Okay, so that's too large, greater than 5%. So my rejection region has come out as x is less than or equals to 2. What's the probability of type 1? Error is the probability that I just found out, 0.442. Yep, that's the correct answer. Critical region is also correct. Then it says, in fact, 3 patients out of 30 do not arrive. I've calculated the probability of 3. State the conclusion of the test explaining your answer. So I'm going to say that part 5, 3 is in the acceptance region. So not enough evidence to conclude that P is less than 0.2. Okay. Moving quickly on to question number 5. It says at the last election, 70% of people in Napoli supported the president. Luigi believes that the same proportion support the president now. Maria believes that the proportion of support the president now is 35%. In order to test who is right, they agree on a hypothesis test, taking Luigi's belief as the null hypothesis. They will ask 6 people from Apple, and if more than 3 support the president, they will accept Luigi's belief. This is Luigi. So this is actually the acceptance region. You are accepting H naught. So your rejection region will be x less than or equals to 3. Calculate the probability of a type 1 error. So I have to calculate the probability of x less than or equals to 3. So that is the probability of a type 1 error. That's the rejection region basically. So I have to calculate 3, 2, and 1 and 0. Okay, again, I can do the cumulative thing, but let me just first write a few. So I'm going to write 6C3, 0.3 power 6 minus 3, 0.7 power 3, 6C2, 0.3 power 4, 0.7 power 2, and so on. Okay, let's accumulate. N is 3, N is 6, and 0.7. So I've accumulated and it has come out as 0.25569. So that's 0.256. It's the probability of a type 1 error pretty high compared to the reject because it's a very small sample, I think. If Maria's belief is true, calculate the probability of a type 2 error. Maria's also told you that 35% is what she believes. Okay, so type 2 error is probability of acceptance region with new p. So acceptance region is x is greater than 3. So I'm calculating the probability of 4, 5, and 6 with the new p. So 6c4 0. Now p is 0.35, so q is 0.65, 6 minus 4, 0.35 power 4, 6c3, 6c5, 0.65 power 6 minus 5 and 0.35 power 5, 6c6, 0.65 power 6 minus 6, 0.35 power 6. This is going to take me a little bit of time because I'm going to use binomial probability distribution where I accumulate on a where I write down things on a list. 4, 5, and 6. N is 6 and 0.7. Yeah. So I get 0.3241 plus 0.3025 plus 0.1176. 0.7442. Okay, now I've taken on the wrong P. So this is wrong. 4, 5, 6. N is 6 and 0.35. I have 0.951, 0.0204, and 1.838 into 10 power minus 3. Zero 0.117. That is indeed the correct answer. In fact, six people say that they support the president. So two falls in the rejection region. Okay, two falls in the rejection region. State which type of error, type 1 or type 2 might be made. So if it's in the rejection region, you will reject H naught. Therefore, a type 1 error could be made. Okay, you reject Luigi's belief when it is actually true. Okay, question 6. A cereal manufacturer claims that 25% of cereal packets contain a free gift. Lola expects that the true proportion is less than 25, H naught, H1. In order to test the manufacturer's claim at the 5% significance level, she checks a random sample of 20. Okay, my success is 0.25. Find the critical regions. Again, a bit of trial and error. Let's again start with 2 and see if we get our answer. I am not going to write down the probabilities right now because I think that's pretty doable. You have n and p in front of you. I think everybody can write that. I'm just going to put these on my calculator into a cumulative probability binomial distribution and get you an answer for the uh, total. So 2, n is 20, and p is 0.25. So this comes out as 0.0913. I think that's pretty large. So I need to make this number smaller. Let's check if x is less than or equals to 1 works. That gives me 0.0243. So this one works as it comes within the 5% range. So the critical region for this test is x is less than or equals to 1. Critical region is 0 or 1 packets contain the gift. Hence, find the probability of a type 1 error. So that's already there for you. Type 1 error is the probability of the rejection region. So rejection region, probability of x less than or equals to 1, 0.0243. Lola finds that 2 packets in her sample. So she's not in the rejection region. She's outside the rejection region. So except it's not, which means that 25% serial manufacturer is right. Okay. Uh, Question number 7, it is known that whether a certain coin is fair or biased. In order to perform a hypothesis test, Raj tosses the coin 10 times and counts the number of heads obtained. So the probability of head is typically 0.5. Okay. Now it could be biased in either way. So P is not equals to 0.5. This is the first time that you're looking at binomial a test of the population proportion where the alternate hypothesis does not have a direction. Okay, the probability of obtaining a head on any throw is denoted by P. The null hypothesis is P 0.5. Find the acceptance region of the test given that the probability of a type 1 error is to be at most zero point 0.1, which means that your rejection region has to be zero point 0.1. Now, remember that if I were to, sort of draw a spectrum from 0 to 10, okay, my rejection region would be on both sides equally. So I have to find a pair of numbers inside, let's say whatever number this is, let's call that x, and let's call that w. Okay, so the probability between x and w, probability, let's not call that u and v, let's call that u and v, so that's easier for me to. So probability between u and v should be 90% because I want my rejection region to be zero point 0.1 or 10%. So that's a difficult job. So remember that it always has to be symmetric. Rejection region has to be equivalent on both sides. So what I'm going to do is I'm going to start doing a bit of trial and error. I said let's keep that as 1 and let's keep that as 9 for now. Okay, so I'm going to calculate the probabilities from, I know from 0 to 10 it's going to be 100%. So I've closed in on both sides and I've said, okay, let's try and find our acceptance region. If this comes out as 90%, I'm absolutely fine. This should be my rejection region. Otherwise, I'm going to start, if it's greater than 90%, that I'll have to make it narrower. Okay, so what I have to calculate is I have to calculate the probability of 1, 2, 3, 4, and so on up till 9. So there is a bit of trial and error involved. So what I'm going to do is instead of doing all of this, I'm going to say probability of 0 and probability of 10. So let's calculate on my calculator the probability of 0 and 10. I am going to do this with the binomial list 0 and 10. N is 10 and 0.5. So I am getting 9.766 into 10 power minus 4 and 9.766 into 10 power minus 4. It's symmetric. Okay, that tells you something. We'll talk about that later on. Hmm. Okay, so 1 minus 2 into 9.766 into 10 power minus 4. That gives me a 9.998% acceptance region. That's not what I wanted. I wanted something around 90%. So I'm going to make this region narrower. I'm going to say that my region needs to be between 2 and 8, let's say. Okay, so I'm going to calculate the probability of 2, 3 up till probability of 8. So what am I leaving out? I'm leaving out 1 minus probability of 0, probability of 1, probability of 9, and probability of 10. I already have 0 and 10, 9.766 into 10 power minus 4. Um, let's calculate 0 and 1 and 9. 1, 9, 10, 5. Okay, so all of these numbers are similar because my probability of success and failure are both zero point 0.5 in case you're wondering. Um, so I am getting okay, so let's see what I'm getting. I am getting 1 minus 0.9766 into 10 power minus 4. That's twice into 2 as well. Okay. Minus 0.97, 9.766. Okay. Typing mistake. 9.766. 0.766 into 10 power minus 3 into 2. I am getting again 0.9785. That means that my acceptance region is this, and my rejection region is very small right now. Again, my rejection region is very small right now. So I'm still inside the rejection region. If I if I subtract it from 1, I can go at most to 0.1, which means that I must test out another one. Let's test out if staying between 3 and 7 gives us a rejection region that's greater than zero point 0.1. Okay, so it's a tougher question that way. 0, 1, 2, 8, 9, and 10. Okay, so let's 0.9785 and let's calculate the probabilities of 2 and 8 separately and add them together. 2, 8, 10.5. So it's 0.0439 and 0.0439. Let's see if we go outside that zero point 0.1 limit that I set for myself. 0.0439 minus 0.0439. I go to 0.8907. That means that my rejection region is now greater than zero point 0.1, so not possible. Sometimes it stops working. Okay, so my greatest acceptance region can be between 2 and 8. So way more complicated than the previous questions, but that's true about the S2 exam. Sometimes the questions can be tougher, so make sure that you know how to do them. Okay, calculate the probability of a type 2 error in this test if the actual value of P is 0.7. Okay, so acceptance region is basically probability of acceptance using nu P. So I have to calculate the probability of 2 and 8 using nu P. Again, I will subtract 1 minus probability of 0, 1, 9, and 10. Again, I'm going to do these on my calculator because I don't have space here and I am also running out of time. So I'm going to say that for list. What's my new P? My new P is 0.7. So biased. Okay. So 0, 1, 9, and 10. 10 and zero point 0.7. I get 5.905 into 10 power minus 6, 1.378 into 10 power minus 4, 0.121, 0.0282. Subtract these. 5.905 into 10 power minus 6 minus 1.378 to 10 to the power minus 4 minus 0.121, 0.0282. That gives me 0.851. That is indeed the correct answer. Okay, so long question for 7 marks and difficult one as well. Let's go on to the next one. Question number 8. At an election in 2010, 15% of voters in Bradfield voted for the Renewal Party. 1 year later, researchers asked 30 randomly selected voters in Bradfield whether they would vote for the Renewal Party if there were an election in 2 weeks. So the test statistic came out as 2. Of the 30 voters said they would use a binomial distribution. At the 4% significance level, the null hypothesis that there has been no change for the Renewal Party against the alternate hypothesis that there has been a decrease in support. So I will do probability of x less than or equals to 2, 0, 1, and 2. Okay, I'm doing this again on my calculator. N is 30 and 0.15 is my probability of success. So I'm getting 0.151. Okay, 0.151 is greater than the significance level. So you accept H naught, not enough evidence to say that the support has decreased. Explain why in conclusion in part 1 cannot involve a type 1 error. Type 1 errors occur when you reject H naught. State the circumstances in which the conclusion in part 1 would involve a type 2 error. Um, when P was actually less than, so there was a new P involved. That is when you would end up with a type 2 error. Okay. Question 9. Deng wishes to test whether a certain coin is biased. Again, it's a biased coin, so it's going to be a two-sided test so that it is more likely to show a heads than a tails. Okay. No, it's telling me that it's more likely, so I can just do a one-sided test. Okay. So probability of head is 0.5, but this time it's saying probability of head is greater than 0.5. So he throws it 12 times if it shows a head more than 9 times. So my test statistic is 9. You will conclude that the coin is biased. Calculate the significance level of the test. So I've told it's not the test statistic actually. If it shows more, he's told you the rejection region. X is greater than 9. The probability of X is greater than 9. So I want to calculate the probability of 10, 11, and 12. That is going to tell me the true significance of the test, and that is going to be my rejection region as well. So I'm going to put out a list 10, 11, and 12 on my calculator. N is 12, and my success is 0.5. So I am getting 0.0161 plus 2.9 into 9 to 9 into 10 power minus 3. It's not 9 to 9, it's 930, and 2.441 into 10 power minus 4. Okay, adding these up. 0.0193. Okay, 1.93% is my significance level, or the probability of a type 1 error, or the probability of the rejection region. That is the true significance level, so that is the same answer throughout. Okay, Deng throws another coin 100 times in order to test. Now 100 N is large. Okay, um, in order to test at the 5% significance level whether it is biased towards the head, find the rejection region for this test. Um, okay, let's think about this, because I will have to convert this into a normal distribution first. Let me check. Yeah, so I will have to convert this into a normal distribution because n is very large. So let's say I call the rejection region start to be x is greater than or equals to c, because it's going to be matching the sign. Okay, I don't know what c is, but I know that whenever I convert a binomial to a normal, I will have to do a continuity correction. So continuity correction gives me x is greater than c minus 0.5. Okay, and I'm converting this to a z, so I'm going to say that np minus np divided by root of np cube. What I want is I want this to be in the critical region, so I know that my probability should be either less than or equals to 5%. Okay, that is what I want from my critical region, that it should be less than the significance level. That is by how a binomial works. So let's see if I can work this through. C minus 0.5 NP will give me 100 into zero point 0.5 will give me 50, and then 100 into 0.25 will give me 25 is less than or equals to 0.05. Okay, that gives me 1 minus phi of c minus 50.5 over 5 is less than 0.05. 0.95 when I subtract it from 1. I've just changed sides right now, nothing else. Phi inverse normal. 1.645. Okay, so 1.645 into 5 plus 50.5. C is greater than or equals to 58.725. So yeah, C is greater than or equals to 59 should be my critical region. X is greater than or equals to 59. Okay. Okay, because I described the critical region as X is greater than or equals to C. Now C can't be a decimal number for that matter. If it has to be greater than or equals to 58.725, then the first integer value that I have is 59. Okay, difficult question. Let's do the last one for this marathon today. It says Lila supports that a particular six-sided die is biased so that the probability that it will show 6 is greater than 1 over 6. Okay, so she tests the draw die by throwing 5 times. If it shows a 6 and 3 or more, um, she will conclude that the die is biased. So she will accept, reject H naught. So that is my rejection region. State what is meant by a type 1 error in this situation. Type 1 error means rejecting H naught when it is true. So in this case, I can say that um, concluding that the die is biased when it is not. Okay, and calculate the probability of a type 1 error. So probability of x greater than or equals to 3. So 3, 4, and 5. Let's quickly put that on a list in our calculator. 3, 4, 5, minus 5, 1/6. So I'm getting 0.0321 plus 3.215 into 10 power minus 3, 1.286 into 10 power minus 4. 0.0321 plus 3.215 into 10 power minus 3 plus 1.286 into 10 power minus 4. I am getting a bit of a rounding of error. It's absolutely fine. It has to happen in some decimals. Okay, assuming that P actually is 2/3, calculate the probability of a type 2 error. So type 2 error is accepting acceptance region with new P. So probability of x less than 3 because rejection region had greater than or equals to 3. So I'm going to say probability of 0, 1, 2. Yeah, that's pretty much it. I'm going to use the cumulative distribution on my calculator and try to come up with a final answer quickly. And my new P is 2/3 that's given in the question. 2099 or 210 rounded to three significant figures. Okay, Lila now throws the die 80 times and it shows a 6 on 50 throws. Calculate an approximate 96% confidence interval for P. This is a bad confidence interval, so let's do that. The confidence interval for proportion is the sample, which is 50 over 80. That's 5 over 8 plus z-value. The z-value for a 96% confidence interval will come from 98% on our table. I don't have 98% on the bottom line, so I'm going to figure out 98% from here. 9798 plus 2, so I'm getting 2.054. Okay, 054, 2.054 into root PQ. 5 over 8 into 3 over 8 over n. N is 80. This has to be a minus here. Okay, population proportion 5 over 8 plus 2.054. Okay, let's put that on our calculator. 5 divided by 8. 2.054 into root 0.514 and 0.736. Okay, that brings us to the end of our marathon for this first part. There are more questions. I am going to solve that in the next marathon, I think. I think we should just have one exercise. There are 5 more questions. We'll solve that in the next marathon. I will see you in the next marathon. Please make sure to like and subscribe if you're watching this video. Thank you for watching.